Hi, welcome to my channel. In this video, we want to compare sine or cosine theta and cosine of sine theta if theta is in the closed interval from 0 to pi over 2. It is hard to directly compare sine or cosine theta and cosine of sine theta, so let's try to convert sine or cosine theta into an expression involving cosine. To do that, consider the expression cosine of pi over 2 minus cosine theta. We can evaluate the expression by using the identity cosine of a minus b equals cosine a times cosine b plus sine a times sine b. For our case, a equals pi over 2 and b equals cosine theta. Since cosine pi over 2 equals 0 and sine pi over 2 equals 1, we thus obtain cosine of pi over 2 minus cosine theta equals sine of cosine theta. Therefore, cosine of pi over 2 minus cosine theta is the desired expression. Next, let's show that if theta is in a closed interval from 0 to pi over 2, then both sin theta and pi over 2 minus cosine theta lies in the same interval. First, let's consider sin theta. If theta is in the closed interval from 0 to pi over 2, then we have 0 is less than or equal to sin theta, which is less than or equal to 1. Since 1 is less than pi over 2, therefore sin theta lies in the closed interval from 0 to pi over 2. Next, let's consider pi over 2 minus cosine theta. If theta is in the closed interval from 0 to pi over 2, then we have 0 is less than or equal to cosine theta, which is less than or equal to 1. Multiplying the inequality by minus 1, and then adding pi over 2, we obtain pi over 2 is greater than or equal to pi over 2 minus cosine theta, which is greater than or equal to pi over 2 minus 1. Since pi over 2 minus 1 is positive, therefore pi over 2 minus cosine theta lies in the closed interval from 0 to pi over 2. Following this, let's show that pi over 2 minus cosine theta is greater than sin theta. To do that, consider the expression pi over 2 minus cosine theta minus sin theta. After writing it as pi over 2 minus cosine theta plus sin theta, we multiply and divide by square root 2 to the terms in the bracket. Since sin pi over 4 and cosine pi over 4 equals 1 over square root 2, we obtain pi over 2 minus square root 2 times sin pi over 4 times cosine theta plus cosine pi over 4 times sin theta. We can simplify the terms in the bracket by using the identity sin a times cosine b plus cosine a times sin b equals sin of a plus b. For our case, a equals pi over 4 and b equals theta. So we obtain pi over 2 minus square root 2 times sin of pi over 4 plus theta. Since sin of pi over 4 plus theta is less than or equal to 1, multiplying both sides by minus square root 2 gives us minus square root 2 times sin of pi over 4 plus theta is greater than or equal to minus square root 2. Therefore, our expression is greater than or equal to pi over 2 minus square root 2, which is greater than 0 since pi over 2 is greater than square root 2. By moving sin theta to the other side, we thus have pi over 2 minus cosine theta is greater than sin theta. Finally, note that cosine is decreasing on the closed interval from 0 to pi over 2. Recall that if a function f of x is decreasing on the interval I, and a and b are in I with b greater than a, then f of a is greater than f of b. Calling sin theta as theta 1 and pi over 2 minus cosine theta as theta 2, we then have theta 1 and theta 2 is in the closed interval from 0 to pi over 2, with theta 2 greater than theta 1. Since cosine is decreasing on the closed interval from 0 to pi over 2, we thus have cosine theta 1 is greater than cosine theta 2. Inserting in the expressions for theta 1 and theta 2, we obtain cosine of sin theta is greater than cosine of pi over 2 minus cosine theta. Since cosine of pi over 2 minus cosine theta equals sin of cosine theta, we therefore obtain cosine of sin theta is greater than sin of cosine theta, which is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.